Okay. Okay. Um, so someone has the mic on. Please, can you mute it? Okay, so today we're going to see module 6, decoupling your infrastructure. Can anyone tell me what decoupling means?
Disconnect, separate,
Disconnect.
separate, disconnect,
Okay.
run independently.
Yes, that fits better. Yes. You know, I don't depend on you, you don't depend on me, but we are somehow connected. Okay. So if you fall down, I don't go down with you. Okay.
Yep.
So that's what it means, right? So we're going to see part 1, loose coupling. That's what, decoupling means. We can have tight coupling and loose coupling. In this case, the way to go is loose coupling. So loose coupling strategies, communicating easily and reliably among components, communicating easily with loose coupling and Amazon DynamoDB, Amazon API Gateway, serviceless architectures, and decoupling examples. After completion of this module, you will be able to articulate the importance of making systems highly cohesive and loosely coupled. Recall the multi-dimensional facets of system couplings to support the distributed nature of the applications that they are building for the cloud. Right? So loosely coupling. We have here the anti-pattern. Okay. We have here some web servers and app servers that they depend on each other. See how they are connected to each other? That is absolutely crazy, right? This is crazy. And they're tightly coupled, all of them, one to another. Okay. So if this one goes down, this one will go down, this one will go down. It's the anti-pattern, right? So as an architect, we have to design architectures with independent components, right? We have to be able to separate your application into small microservices, okay? To be able to work independently, and then at the end of the process, bring them all together and they work together. But they're still independent on each other, okay? They work together, but they're independent. That's all about decoupling, right? Loosely coupled. So the best pattern here, we have 3 web servers, and then we have an elastic load balancer as the single point of entry, right? So you are decoupling these servers from these servers, okay? So this is the decoupling element here, okay? All the traffic has to come through this guy, the load balancer. So what we're doing here is reducing the interdependencies, so that the change in value of one component does not affect other components. Okay? So as a solution architect, you have to think about this best practice. Okay? And have this guy in the middle, the middleman here, as the decoupling factor here. Okay? So loosely coupled. The more loosely your system is coupled, the more easily it scales, right? Tightly coupled, it limits scalability. Okay, it limits that. Loosely coupled is better for scalability. Okay, so we have the same example as before. Okay, tightly coupled, loosely coupled. Okay, so one moment. So in this example, loosely coupling simplifies the process of scaling, and tightly coupled, what it makes is makes it more difficult, right? So what it does, if you're using a distributed system and multiple tiers, for example, you have the web tiers and the app tiers, a managed load balancer or queuing system provides a single point of entry, like I said before. Okay, so think about that when architecting an infrastructure. Okay, so Same thing, it's showing you that, if these components go, this one goes down, so the other three will go down too, because somehow they're connected to this one here. All right. If this one goes here, the same happens. All this guy will go down as well. So same here. If this three go down, or one of these go down, the other ones will go down too, because they are interdependent. Okay, and we're shooting for eliminating interdependencies. Okay, strategies. So leverage the breadth of AWS services. Don't limit your infrastructure to servers. What is the anti-pattern, right? Simple applications run on persistent servers, right? When you design, make sure that you leverage the breadth of this, right? In the anti-pattern, simple applications run on persistent servers. The application communicates directly with one another by static IP or host names, right? The static web assets are stored locally on instances, and backend servers handle
I'm
you.
sorry, Professor, I cannot hear you.
There's someone here. Can you please mute your phone? Whoever. Okay, I did already. So you have to run these on persistent servers that, you don't have to. This is the anti-pattern, right? You have to be able to do it in a serverless manner. One moment, please. What is the best practice for this? You can do it as a serverless solution at the time of need, right? This is very good. For decoupling, serverless is better, much better solution, because you don't have servers that depend on each other, right? And when you need them, you use them. If you don't need them, don't use them. So the anti-pattern is to use persistent servers all the time, Applications communicate directly with one another. So this is not good, right? We have to have a decoupling factor like this guy here, right? In this case, we have a load balancer. We can have a queue as well. We're going to see SQS later. And you can have a message queues that handles communication between applications. So you're going to have a producer and a consumer, okay? Two applications consuming the message from that queue, okay? And then that queue works as a decoupling element to preserve that message or that particular instruction, right? If one goes down or the other one goes down, the message is already in the queue. So if you hear in the exam that they need a decoupling service, and one of the options is SQS, that's the answer. That's the answer. SQS, we're gonna see later, is one of the services that companies use to decouple their application. Okay, so don't let your servers to communicate with each other. Don't let your applications to communicate with each other. Okay, use something in between, either a load balancer or a queue service to decouple that application. Okay, very important.
Yeah, I saw that on the cloud practitioner exam. They mentioned decoupling and
Yes,
what service would help you with that.
that's right. Okay, so static web assets are stored locally on instances. Don't do that. Do it on S3. Okay, don't do it on your server, right? On your EC2 instances. Don't do that. That's the anti-pattern. That's not recommended. The best place in the entire AWS architecture or infrastructure to save static assets is Amazon S3. Right? That's the best place. And you can access it through the URL or the console, whatever you want to do. And this is serviceless. Okay? It's using services architectures, Amazon S3. Okay? Backend servers handle user authentication and user state storage. Don't do that. User authentication and user state storage are handled by managed AWS services. Have the managed AWS services handle that. like Cognito or any other STS, like simple token service. Those services are the ones that you should let handle authentication. Okay. Service-oriented architecture, very popular nowadays. The SOA is very popular. It's an approach in which application components provide services to other components via a communication protocol. So in general, what it does is it makes the application modules available in a way that makes implementation details irrelevant. Application users are no longer concerned with implementation details like operating system, language, or location. Services are available via an endpoint, okay? So you want to access a specific resource, you can do it through an URL, and that's it. You don't need to know about the details or implementations, okay? So this is a very popular architecture right now. Services are self-contained units of functionality where the implementation details are no longer relevant. It's no longer to the user. It's like, for example, now you want to buy a car, right? You want to buy a car and you get a manual that has all the, explanation for some of the functionalities of the car that are relevant to you, right? As a user. But you're not going to receive information about how the radiator works or how the different, the chassis, whatever parts that you don't see that are under the hood. They're not going to tell you anything about that. The implementation, those details are irrelevant to you as a user, right? So what is relevant to you is the things that you need to know, okay? So that's similar to service-oriented architecture. The units of functionality are self-contained, these services are self-contained, and this is where microservices come in, right? And you don't need to know about what is not relevant to you, guys. Everything has been abstracted away from you. So microservices, for example, is small, fine-grained, independent processes in SOA. So let's say that now you want to build an application, a full stack application, and it's about a survey to users, right? And you have several teams working on every specific feature of the application. For example, you want a team to work on the profile of the users. You want a team to work on the surveys, right? And you want another team to work on the interviews that the customer has to go through, right? Something like that, right? They're looking for a job, for example, or let's say that it's a service like a training service, like this one, for example. You're receiving training from Miami-Dade College, and we're gonna build a full stack application that just gets the information from the users. And let's say that this training in the website, you have a section that is for surveys, right? How the program did, how the professor was well prepared, and everything went well with the course and everything. And also, let's say that this program also provides jobs for the users, for the students, right? We're going to have another team to work on the job interviews, right? How you can conduct a job interview with those students. So we have three different sections. We have users profile, we have user surveys, and we have users interviews. So we can have three teams working together, and you can separate each team with one microservice, right? One microservice can be the surveys, one microservice can be the interviews, and one microservice can be the user's profile. Now, they're going to work independently, right? Independently, right? So developers can work on the user's profile without needing any other microservices, right? For now. At the end of the day, they're going to be all connected, right? You're going to bring them together, and that's why you have the entire application. But microservices, they're small, fine-grained, and independent processes in the service-oriented architecture, right? So each process is focused on doing one small task. We're doing the user's profile, we're doing the user survey, and we're doing the user's interviews. Small services, small task, right? Processes communicate to each other using language agnostic APIs that leverage JSON or REST. So we can use REST, and REST stands for representational state transfer. Representational state transfer. Very popular nowadays. REST APIs, RESTful applications, where you use URLs as the, it leverages URLs to get resources from the URI, from the URL. Because you can use, for example, an ID from the URL. For that, you guys need to study a little bit of RESTful applications. That's even more complicated if you have no knowledge about full stack applications. I don't want to talk about that now because that's not relevant for this exam, but at least you should have an idea how RESTful applications work. And also about JSON. JSON, yeah, you have to know more about JSON, because JSON has to do with many services in AWS. All the policies in AWS are written in JSON. All the policies, IAM policies, bucket policies for S3, service level policies for organizations. So all the documents, policy documents in AWS are written in JSON. So JSON is super important. DynamoDB is created using JSON format in the background. So JSON is a super important object notation. So I highly recommend, digging deeper a little bit in JSON. Okay. Microservice examples, for example, Chaos Monkey logo by Netflix. Okay, and Simian Army logo by Netflix. These are some of the things that Netflix has. For example, some important information here says several years ago, Netflix had a data center fire that led them to embrace the microservices standard. Look at this. There had to be a disaster for Netflix to understand that microservices is important. So Chaos Monkey is a tool invented in 2011 by Netflix to test its infrastructure resiliency. Chaos Monkey randomly terminates virtual machines, instances, and containers that run inside of a production environment to test how remaining systems respond to the outage. Okay, very smart. So this provides the opportunity to test a redundant architecture to ensure that a server failure will not noticeably impact end users. If you are a developer for Netflix, you've got to be certain that the code you're writing is going to survive the chaos. Chaos Monkey exposes engineers to failures more frequently and incentivizes them to build resilient services. A second tool, Chaos Gorilla, terminates an entire Amazon availability zone. A suite of tools called the Simian Army can be used to test the reliability, security, or resiliency of the Netflix Amazon Web Services infrastructure. This is what microservices are all about. You can lose parts of your infrastructure and yet your site stays up and you can still serve the customers. Okay, so there was a disaster in Netflix. Okay, one of the data centers caught on fire, and then they developed these two tools to test their infrastructure, right? This one, the Chaos Monkey, it terminates instances and just tests if the infrastructure can be operational. And this one tests, what it does is it just takes the whole availability zone down to see what's happening. Well, guys, maybe you didn't know about these guys before, but from what we can see, if you have Netflix, is that Netflix is very highly available, and it is always, almost always, I wouldn't say always because nothing is 100% perfect, but it's almost always running. It's always running, okay? And I've seen Netflix down, but it's only for seconds, probably minutes, no more than that, right? And if you see Netflix is down, probably is your smart TV that is not connected to the internet, most likely, right? But it's very unlikely that Netflix be down. It's very unlikely. It may happen, but it's very unlikely. Okay. So we're comparing architectural styles. So we have a monolithic application, or this is a traditional service-oriented architecture where everything is uniform, right? Everything is together. It's a uniform thing here. You have all here, home, orders, suggest card, stats, inventory. Everything is together. Everything here, right? So, which makes the job more difficult, right? More difficult because, monolithic applications, you're less available than if you are in a microservice-based architecture. Okay. You can be sure that if Netflix were on a monolithic architecture, Netflix wouldn't be that highly available as it is now. I can promise you that. Okay. So what is very popular right now, like I said before, microservices is becoming super popular. This service-oriented architecture, this is basically is losing all the everything that is coupled, making it loosely coupled, where you have home here. See, home is connected to these guys, but it's independent. So if home goes down, this guy will be, they will still working, right? Because they have been created to outstand any failure in any of the neighboring components right here. Okay, so these guys orders, they have their own microservice here, right? Heart is another microservice. Let's just see this as a full stack application, right? Right. When every team is working on a different thing, right? There's some people working on the card, right? There's some people working on the. Okay, guys, can you hear me?
Yes.
Yes.
Okay.
Yes.
Just give me 1 second. I already contacted Zoom and they haven't responded to me, but I froze again. I don't know why this is happening so frequently in the afternoon class. It had never happened before, but right now I'm frozen. You see that my face is not moving, so my picture is frozen, right?
It's actually, there is no picture.
It's frozen.
Yep.
Yeah, my audio's been choppy the whole time.
You just froze now, right? He's frozen now. I don't know. Is that just me, or is it frozen for you guys too?
Yeah, he's gone.
Oh.
He's probably restarting his
Yeah, he's
computer.
probably restarting his computer. Yeah.
No, usually when he's restarting his computer, he gets disconnected. But this time, I see his name.
Oh.
Now he's gone.
Yeah, now he's gone. Okay.
Okay, guys, I'm back. Can you hear me, guys?
Yeah.
Yeah.
Yeah, we hear you.
I already reported this to Zoom. I don't know why still this is happening. So, like I was saying, just let's see this as a different, different teams working together, okay, for different um, different features, right? One team is working on the card, one team is working on the orders, and the stats suggest inventory. So, different features, loosely coupled, but if one goes down, the other ones can still operate. Okay? So microservices, what they do, it's one moment. Split features into individual components, have smaller parts to iterate on, and have a reduced test surface area, benefit from a lower risk due to change, and use individual horizontally scalable parts. Okay. When it says in horizontally scalable, it means that you can increase the number of that, and then make it work better. Okay. The bottom line of microservices is that you have small tasks. You split the whole thing into little small tasks. Okay, that can run independently, and then at the same time they're working together. Okay, so that's basically microservices. The best practice is you change components without breaking them, right? If I change orders here, home would not be affected, car would not be affected, okay? Because you can change them and not break the other ones, right? So the interface is a contract. So you're working with interfaces more than anything, right? If you know about abstraction, and interfaces in programming, then you can have an idea that you work with interfaces and you don't work with it. It's behind the interface. It's like, for example, let me see if I can have an example. If I have a mask on my face, right? And I want to change the expression of the mask. Do I have to change my face? Do I have to change my face?
No?
What do I change? The mask, right? The mask, right?
Right.
Same thing with the interface and whatever is behind the interface. Okay, so you don't have to work on the code. You don't have to work with anything that might break the other components, right? Because the code might break some other stuff, right? What you have to do is work in the interface, right? You work on what is out, okay? That doesn't affect anything else. So modifying the capabilities should not affect consumers, right? If you modify the interface, it doesn't affect anyone because you're not changing what is behind the interface, right? We can use a simple API, lower the cost of using your services. Instead of modifying your services, you can modify the services from the API, making an API call. For example, in the morning, we created a database using RDS and dbeaver, and I myself create some tables in dbeaver. but I did it manually. I could have used an API, like a program in Java, for example, or JavaScript, and I could have created a table from there. So I don't have to mess with my backend, with my database. I can just make an API call and modify or create the table from my code in JavaScript. I don't have to go there and change it manually. Okay, so that lowers the cost, right? Because it's just a request. I don't have to be creating anything there. So more complexity means more resistance to change, right? So be simple, you know. Don't keep it simple. Don't make it complex, right? Because you're not gonna be the only one working with that. There are gonna be other people working with the same architecture you're working with. So the more complex you make it, the more Chinese is gonna look to other people. So it's gonna be very complex to understand. It's like reading Chinese. I don't know anything. It's one of the most complicated languages that you can even. They don't even have a Latin alphabet, so that's why it's so complex. Like Japanese, Arabic, or Japanese. Those are difficult languages, right? So the more complex, the more unfamiliar the structure is, it's going to be more resistance to change. It's going to be more difficult to change it. So keep it simple, like the acronym KISS. You know, keep it simple. Some people say keep it simple, stupid, but I would say keep it simple, student. You know, it's better. So the less you share, the less will break. Okay, we don't want to share what is not relevant to the user. We want to share what they can see, right? What they can see. When you show people a website, you show them the GUI. The GUI is the graphic user interface, right? What they see is they just enter information or click on a button or something. You're not sharing anything important, because if you share something important, someone might break your code. Okay. Of course, I don't think someone's going to be that naive to show a customer the ins and outs of a specific code behind the scene. No. But when we're talking, you know, among developers or among architects, you know, the less you share, the less will break. Give architects permission based on their role in the company. You know, you just deny everything, and then you start granting permission as, you know, the need arises. But the less you share, the less will break. Allows you to hide details. This best practice, you hide the details because you only show the interface, and the implementation of the details are hidden. They're abstracted away from the user and from people that don't need to know about that. Okay, that's very important. Those are the best practices for microservices. We have more. You keep it technology agnostic, enable change, be ready to embrace the next evolution step. Okay, you have to I mean, software needs to be revolutionary. It has to evolve over time, right? You have to keep something open to be able to embrace whatever change that comes in the future. If something evolves, your infrastructure, your architecture has to be able to cope with any change, any modification. So this is very simple. Not very simple, very important, okay? Always design with failure in mind. Why? Because, you know, the guy that the CTO of, you know, of Amazon said that everything fails, right? Everything fails. You have to think, you have to prepare and plan for failure, okay? If you're an architect, you want to architect for a company, one of the first things that you have to think about is failure. You have to plan for failure. You have to think of failure, because you don't want that customers to go back to you and tell you, hey, where's this failing? And if it is something that you could have fixed before you even started, okay, you're going to be embarrassed, right? They're going to think that this guy doesn't know what he's doing, or he's not prepared for the job. and you might lose that contract, right? You may lose that connection because you're not showing, you know, that you know what you're doing, right? So always think about failure. Failure is important, right? Failure scenarios happen all the time in production, right? You know, in testing, you may test it, but what about production? What if it fails, right? So you have to think about everything, okay? And if something escapes you, I mean, things happen, okay? You're not perfect, right? But think about things that you can fix from the get-go, right? That's why, you know, these guys, Netflix is, you know, Netflix is a huge company. They were not ready for a fire in a data center, right? So they were not ready for that. But immediately, they created a strategy right now. Now, if there's a fire, you know, they know what to do, right? Because they are, you know, prepared in advance for that, right? So they rarely happen during testing unless you force them to, right? So you're testing your environment. Disaster happen, but you know, when you are in development, disasters don't happen, right? Unless your entire you know, office is down or something, I don't know. And testing, I mean, you only testing them, right? And if you want to test your environment, you can force a test and then just shut everything down and see if my infrastructure is resistant and resilient and fault tolerant, that it can be still up and running, right? But you know, in development, none of this happens unless you force it to. But in the production, that's what when it counts, right? That's when it counts. So you have to be ready for that. Design for failure. Okay. Monitor your environment, not just infrastructure. Extracting health status means collecting it from services, right? You have several services that extract the health status. Elastic load balancer is one. Auto scaling is one. Cloud watch is one. The health status, the personal dashboard. Okay, this guy I think is health. The AWS I think is AWS that Amazon I think is, if I'm not mistaken. Yeah, I immediately realized it was now when I said it's not secure, that's not Amazon. Okay. A status that AWS, not health status, right? So we have this guy here. You know, it's the guy that tells you all the services that might affect, you know, the entire AWS infrastructure. Right now, Alexa is working properly. Amazon API in Montreal is working properly, right? So these guys, are you listening to me?
Yes, we
Yeah.
are.
Okay.
Yes.
Yeah, we're keeping track.
Okay. All right. Thank you.
Yeah.
No, it's just that I'm not used to so much silence. Okay, no problem. So these are the guys that, you know, this guy here is the one that tells you, you know, the health of services in AWS, right? But if you want to be more specific to your infrastructure, then you can click on the personal dashboard, right? And this is the one that tells you what affects your infrastructure. Okay, so if you click on see all issues, for example, a batch operational issue in region US West 1, you know, there was an issue there, and then that was last week. I think it was Saturday, right? Saturday at 10:30 p.m. UTC, and then it was fixed like 2 hours later, right? So this might affect your infrastructure, because if you have something in US 1, SQS was having an issue here. Okay, SQS, we're not talking about SQS today. This is a very important service, because if I want to decouple my infrastructure and then SQS is down, how in this world can I keep my application loosely coupled if I'm using this guy. Okay, so this is the guy that tells you, that helps you with your services, the ones that pertain to you. Okay, the other one is the entire AWS infrastructure. All right. Right? The best practice is you treat servers as stateless, right? This is something that we have spoken about before. Okay, stateless means that they don't keep track of the state. Okay, so in other words, state is not important. So you just dispose of them when needed. Just create more if you need that. Service should be seen as interchangeable members of a group, right? It means that I have one server, right? And I don't need it. I terminate it, create another one if I need it. So they're just members of a group and they're stateless. They're not important, okay? They're important when they're running. If we don't need them anymore, they're not important anymore. They just go, okay? So instead of focusing on servers and all that, focus on if you have enough capacity to handle your workload. That's more important than just, oh, this server is very important, I'm gonna keep it. No, servers are not important, because when you create more, you create exactly the same server. So they are interchangeable, right? So adding or moving instances with auto scaling is much easier with a stateless approach, okay? Thinking that they are not important, right? That's we're not keeping track of anything. No state, right? Auto scaling has a configuration behind it that has the skeleton of the server and will create all instances the same based on that launch configuration, okay? Communicating easily and reliably among components. So we have this guy that we have spoken about so many times, and this is the time when we have it here with us. So SQS is a fully managed message queuing service. Transmit any volume of message at any level of throughput without losing messages or requiring other services to be always available. Okay, so this guy is decoupling anything, right? It doesn't require any other services to be available all the time. In its own, it's always available. Okay, very helpful in serverless architectures. This one and SNS, simple notification services, they are used for serverless applications as well. Okay, so the the size of any message has to be 256 kilobytes or less. Okay, or less. It's generated by one component to be consumed by another. Okay, one component generates the message. Let's say that one component receives the order, right? One component receives the order in your retail store online, receive the order, and one component will process the order. But in the meantime, the order is going to be in a queue waiting to be processed, right? Very important. It supports multiple readers and writers on the same queue, readers and writers. Okay. And repository for messages awaiting processing, right? There's a repository for that. Acts as a buffer between senders and receivers, right? Now, there's something called dead letter queue. A dead letter queue. Okay, if you go here, SQS, and you get started now. So you're gonna get here just my first queue. So you can choose either standard or FIFO. FIFO stands for first in, first out. Okay. Now in a FIFO, order is guaranteed because the one that comes in is the one that comes out. If you want to have an and queue with order matters, FIFO is the answer. Okay. If you want to have a queue with when order doesn't matter, standard. Okay. So you have here 1, 5, 2, 4, 3, 3. There's no order here, right? But if you have 1, 2, 3, 4, 5, that's the sequence here. So let's say that you have a retail store. Which one would you go for? Now, not a retail store, because in retail store you may have several orders that are more important. Let's say that the ones that have a shipping that is 1 day, they're going to be processed before the ones that have a standard shipping like 3 or 5 business days. So for that one, you can use standard, or maybe you can use a queue for a queue. Not maybe, that's the way it is. Use a queue for expedite shipping and a queue for standard shipping, right? Now the order doesn't matter because customers don't know which one is before me, right? Which one is ahead of me, right? It doesn't matter. I mean, the customer doesn't know that, right? So I don't know how strict these people can be if they choose a standard or FIFO, okay? Because when it comes to an order, that doesn't matter, okay? But in the case of a phone call, right? There's a phone call, and they tell you that your phone call will be answered and as it was received, right? So the first one that was in line in the wait list is going to be the first one to be answered, right? So there's some instances when order is important, okay? To keep a standard sequence is important. There's some instances when order doesn't matter. I don't think, like I said before, I don't think that for specific retail store online order matters unless you have a queue for, even when you have a queue for expedited shipping, order doesn't matter as long as all the orders are processed, right? Because no one cares if my order was before Carlos's order. That doesn't matter, right?
Well, it will matter for logistics, right?
Yeah. For quality assurance, all that, it matters, right? But for the customer, it doesn't matter. Because the customer doesn't know anything. It depends on how structured the company is, right? If order matters, then you have to use for an ordered queue. If order doesn't matter, okay. Very important here, okay? At least once delivery, okay? At least once delivery. A message is delivered at least once, but occasionally more than one copy of a message is delivered. So that's not good. Can you imagine if the order is processed 2 times and the customer gets 2 packages instead of 1? Okay, that's not good, right? So the best effort ordering, occasionally messages might be delivered in an order different from which they were sent. There's a best effort offering. It will try at all means to deliver the messages in the order they came in, but that's not guaranteed. Okay, that's not guaranteed. Now with FIFO, first in, first out delivery, the order in which messages are sent are received is strictly preserved. Okay, and exactly one processing. A message is delivered once and remains available until the consumer processes and deletes it. Duplicates are not introduced into the queue. This one may accept duplicates. So for this one, you have to use some other configuration. Like, for example, there's one section that you can deduplicate, something like that, and not receive duplicates. Okay. This one, has its own use cases. It depends on the whatever you're trying to accomplish. But this one is very popular too as well. So I can click here, create the queue, and then the queue here it's created, right? It doesn't have any message. Okay. I have some monitoring here. Okay. Lambda triggers. I can trigger a Lambda function. As you can see, there's a Lambda is everywhere. Lambda is a super important service, right? Queue actions, I can send a message, right? And just put a message here. This is my first message. You can put a name here, value, whatever you want to do here, auto attribute, and then send the message. The message has been sent. Okay, let me check here. I have one message here. Okay. Of course, this is just for testing, right? I'm testing it now. It has to be integrated with all the services, right? And the service would be, the other service would send the message, like an order, for example. And then there was going to be another service consuming this message, right? Like the portion that processes the order is going to consume the message from here, right? And after 3 times, for example, if it doesn't consume, something happens, this will go to something called a dead letter queue. There's somewhere here. Create a queue. You can give it some configuration here. A dead letter queue. You see here? You give it a name here. This is the name of the system queue that will serve as a dead letter queue. So all the messages that are not processed after 3 attempts, then you can, it will automatically be added to the letter queue. Okay, so you can have here, maybe you want to accept only messages that are 100 kilobytes, but the maximum is 256, right? The retention period, the default one is 4 days, but the maximum is 14 days, right? So they're gonna be there for from 1 minute, right? Up to 4 days if you leave it default, or you can just put 14. If you put 15, it's gonna give you an error because it has to be 14 or less, right? This visibility seconds is the visibility timeout is the moment from which the consumer picks up the message until it is processed, right? So you have 30 seconds here. So the other component has 30 seconds to consume that message, right? And no other component will be able to see that message until that message is consumed and put back in the queue. Okay, so the length of time in seconds that a message received from a queue will be invisible to other receiving components. That is the visibility timeout. Okay, very important. You can increase this, is between 0 and 12 hours. Of course, if you put 13 hours, is not valid. Okay, so we see 4 minutes, for example. You want to keep it 4 minutes. I want that message to be 4 minutes invisible. Invisible is not because it's there, it's because it's being consumed by the consumer, by the other component, right? If after 4 minutes it's not being consumed, it goes back to the queue and then it's visible for another component to take it. Okay, so you can either leave it here, whatever number, or just increase the visibility timeout. Okay. So send messages into the dead queue letter after exceeding the maximum receives, right? If you can put here, you know, the maximum receives, I can send it here to queue letter, and then, you know, I can give it a name here, anyway, my dead queue letter. Maximum receives, let's see, 3. Okay. Fine. And then this is my second queue. Okay. And we can make it 5 FIFO if we want We can encrypt the messages, use SAE, you know, encrypt the messages if you want to. We don't need that now. So specify the name of the existing dead letter. Oh, there's no existing dead letter. Okay, not a problem. I can create that later. But you know, basically you can create a dead letter and then send those messages from this queue to this queue letter after 3 times, you know, attempts, you know, and it's not processed. Okay. Okay.
So this message goes simultaneously to all components or one by one?
No, the one that the request is. Okay,
Okay.
it's one component per when the message is being consumed by one component, it's not visible to the other components.
Okay.
For 30 seconds is the default one. Well, what's the default one that comes there? First, it's
30
from
seconds.
1 second to 12 hours.
Mm-hmm.
Okay, so okay, so you can name it dead queue, whatever you want to name it here, and then you can say dead queue, right? And then the queue, and then this one I get configured somewhere here. Okay. I think that, you know, when you create another one, then you can specify this guy here. Configure it here, and then just give it a name here. I have to see how I somewhere here. I have to see that. I think they changed this a little bit. Don't worry, that's not important now. I figured it out. It's not important now. So Amazon SQS queue types, standard queue, once at least one delivery, like I explained here. When you create the queue, you know, it gives you the explanation right here. It's at least one time. It's one delivery, and the best effort auditing right here. Okay, and the FIFO queue exactly once processing right here. Okay. And duplicates are not introduced, limited throughput up to 300 send receive delete per second. Super fast, right? So it can do 300 at the same time. I mean, that's super fast and super convenient. All right. So loosely coupling with Amazon SQS, the queuing chain pattern enables asynchronous processing, right? So we have here and three EC2 instances. So they want to put a message into the queue, right? So they put here, right? So then these guys here, they get the message, right? This is the sender, and this is the receiver, right? Okay. Let's say that this is the producer and this is the consumer, right? And then the consumer becomes a producer and sends to another queue, right? To process the job, right? And then these 3 guys here, they will consume the message, okay? So it's all asynchronous. It doesn't happen, you know, it takes some time, right? So then the message has to be deleted from the queue, right? If it is not deleted from the queue, it's going to stay there. So that's something that you guys have to remember. The message has to be deleted from the queue. Okay. Otherwise, it will be consumed again. And you don't need that. Of course, you can automate that, right? But it has to be done. The queue doesn't delete the message. Okay, very important. So Amazon SQS has some benefits. It's very highly scalable, potentially millions of messages, right? Don't forget that the maximum a message can be is 256 kilobytes. It's reliable because all messages are stored redundantly on multiple servers and in multiple data centers, okay? So whenever you store the message, they're gonna be stored redundantly, okay? They have simultaneous read and writes, right? They are asynchronous, but simultaneous at the same time, right? And secure API credentials are needed. You need some authentication to be able to work with the queue, okay? And for that, you will need a role. Role is what is used to interact with other services, right? That's AWS 101. A role is needed to connect to other services all the time. Okay. So we have here some message ordering. You queue distributed on SQS servers, right? Several messages here. So at least once versus exactly once. Okay. So at least once is standard SQS, and exactly once is FIFO, right? You have a dead letter queue support, right? You distribute systems components, component 1, 2, and 3. Messages received from sample servers, right? So these are the guys that are going to consume the messages, right? The server sends messages. This is like a high level overview of how the queues work, right? More or less, right? But you have to know that at least once it's standard, where order is not guaranteed, but there's a best offering here that will try to deliver the messages in the order they were received. And also duplication is possible, okay? But this one, it's only one time. There's no duplication, and the order is guaranteed for sure. Okay. Visibility timeout, I explained to you about this already. It prevents multiple components from, Anand, this is for you. Multiple components from processing the same message. It's only one message per component.
Right.
Okay. So as long as the message is being consumed, no other component would be able to see it. I think it's the security measurement, because if the other components can still see it, they might probably take the message, right? Unless you have some configuration that says, even though you can see it, you cannot take it because it's being used. But in this case, you will not be able to see it, so don't even think about it. It's being used, so if you don't see it, okay? When a message, okay, but I have to warn you, right? I have to warn you. If the component is processing the message and the timeout is passed, the message will go back to the queue, even though the component may be in the middle of the process.
Mm-hmm.
Okay, so what is the solution for that? Increment the visibility timeout. If you think that your components might take more than 30 seconds, increment the timeout. Okay, so the component have enough time to process the order or whatever message it is. So when a message is received, it becomes locked while being processed. This prevents it from being processed by other components. You don't want the message to be processed 2 times, right? So the component that receives the message, oh my God, it's process it and then deletes it from the queue. That component has to delete the message. Okay, it makes sense that if I process a queue message, I myself delete it because the other guys don't know whether it was processed or not. They just see it in the queue, right? It is me, the one that knows if I processed it, so I delete it. Okay. If the message processing fails, the lock will expire and the message will be available again. Okay. So this makes the application fault tolerant, right? The message will not be lost, right? It's just be visible again, so all the components can take it and process it. But this is
So you have to delete it, or
you have to delete it. So the component processes it and deletes it. You have to delete it from there. Okay, so it would not be processed again, right? A dead letter queue is a queue of messages that could not be processed, right? Depending on the retries, right? Why use a dead letter queue? It can sideline and isolate the unsuccessfully processed messages, right? Let's say that you place an order online, let's say at JCPenney's, right? And then your message will be placed in a queue, your order, right? But let's say for some reason the company could not verify your billing information, right? So that order would be canceled and it would be placed in a dead letter queue. Okay, there it would not be processed, right? So you would have to place the order again. So they try to verify your information, but some reason the phone number or the billing address, for example, the street number didn't match the street number that is in your bank information, and the order was not processed, right? So it took certain time to verify your information, but let's say that your component takes about probably 5 hours to process your order, and it took 5 hours for them to know that your order is not processable because there's a mismatch in the billing address, right? So this is very important because at least you can have an idea that there was an order that it was not processed, right? Of course, you don't see this. I mean, the people that work at a retail store online, they don't see this thing happening behind the scene. They don't see that the order was placed in a dead letter queue. They just see cancel orders, and then underneath you see the different cancel orders. But behind the scene, if you're using AWS, you're going to realize that this message was placed in a queue. If you configure it that way, remember that here, I have to choose when I configure this, I have to put here, use a read-write policy and put it in the letter queue. Okay. So the fact that this supports a dead letter queue doesn't matter that the message is going to go there automatically. You have to enable it. Okay. If the message processing fails, okay, that's fine. We know that already. It restores message flow when FIFO is enabled and a message cannot be processed. Okay. It restores message. If the message is not processable, then it restores that. Okay. FIFO, remember, is by order. Okay. Then that message will be put in a queue letter, and then the next one will be processed. Okay, by order. A dead letter queue must reside in the same account, of course, an AWS region as the other queues that use the dead letter. Okay, so in this case, I created mine in North Virginia, the one that I created here. So I can cancel here. And this one, this particular one, it's in, this one is in North Virginia, right? So by the way, the actions that you see here, you can see them here too by right-clicking. Okay, right click and you see the same thing. You can make SQS work in conjunction with an SNS topic. They can work together, and this is what they call a fan-out technology architecture. When you have both of them working together, like this guy couldn't process the order, sends the message to an SNS, and then the SNS sends a message to the user telling you order was canceled. It could not be processed. Okay, so they can work together. This guy doesn't send any notification to anyone. Okay, this is just for processing messages, right? But if you want to have like in some sort of notification thing, then you have to use a topic, for example, my very first topic, right? And then subscribe, right? Then that one is subscribed to that. So I can create, just making work together. Okay. Pretty helpful. All of these things working together. I don't know if you've heard the expression a spaghetti ball. Have you heard that? Spaghetti ball? Never? Maybe? Yes? Well, Amazon,
Not in this term, no.
AWS is considered a spaghetti ball. With everything is so intertwined and so connected, and it looks absolutely crazy. Like when you have a spaghetti ball, you don't know where to start. It's something like that. But everything can work together. Every single service, they can work together with the others. They have a lot of integration. Okay. A shared queue. A queue can be shared with other AWS accounts and anonymously. Okay, so you can do that too. You can share with another account. A permission gives access to another person to use your queue in particular way. So if you come down here, okay, in this case, everybody can use my queue, right? And I have like a condition here. Okay, everybody can use my queue. So in this case, we have my permission here. I just subscribe to an SNS, right? So the SNS, if it is equal to this, then they can have an association with this. I can create more, right? Allow, and then you can put the account number here. You say everybody here, everybody. Okay, and then I can say here, queue URL, or get things, or purge the queue, and I can just add the permission. And then there's no condition here, right? So everybody can come here and purge my queue, like purge it, like just clean it, like this. Right now I have only one message, so if I purged it, there's no message now. So everybody can do that, okay? Which is not recommended. That's not recommended. So I can put a condition here. Okay. So we can put a string equals, for example, a source or secure transport, probably here I can put TCP or something like that, and then change that. Okay, so I can have this here. Everybody can just purchase this queue as long as the transport is secure. As TCP, like transfer portable. So those are permissions. It's like policies. You can have, this is a policy. As you can see, this is a JSON file, right? It's a JSON document, and it's exactly the same as what I put here in the permissions. So when you create permissions, what it does is generates a policy, okay? It generates a policy for you guys. Okay. So they ask you a question here, what is a policy? Maybe you can see here. That's a policy that maybe I can add here and put it in the chat. Maybe you want to know more about SQS policies. A policy is nothing else than a JSON document that either allows or denies permissions, access to this queue, okay, or any service, okay. It says advanced because you have to know, you have to have some knowledge on JSON. If you put something wrong here, you eliminate that, it's gonna tell you fail to save, error, parsing JSON, syntax error. So you gotta be careful with JSON, okay? And you know, be careful with JSON. It's a little finicky when it comes to the syntax, okay? So a policy is the actual document that contains the permissions you granted. You pay for shared queue access. Okay, who pays for the owner? The owner is the one that pays for queue access, okay? Because you're the one that's sharing it, right? If you share it, you pay for it, right? Amazon SQS queue use cases for work queues, buffering batch operation, request offloading, you know, it's decoupling, fan out, just in case you want to use it with SNS, auto scaling, very important. Okay, so to use fan out, combine Amazon SQS with Amazon SNS to send identical copies of a message to multiple queues in parallel for simultaneous processing. So Amazon SNS, that's the other tough guy. You know, all of the guys we're seeing today, they're tough guys, okay? This is one of them. This guy's gonna be, you know, S3, Lambda, SNS. They're gonna be with you for the rest of your lives if you stay in AWS. These guys are everywhere, integrated with every single service. They're everywhere, okay? So Amazon SNS enables you to set up, operate, and send notifications to subscribing services from other applications. Messages published to topic. Topic subscribers receive message. So let me give you a little demonstration. I think I did it before, but I think it was in the morning class. Okay, I can do SNS, right? So in SNS, what you do is, right now I have 9, right? I have 9 topics. Okay, and I have to delete one by one. I don't like that. I like when you can have a checkbox here. You select, boom, all of them are selected, and I come here and delete. But I have to delete one by one. I don't have time for that. So the first thing that you have to do is create a topic, okay? So I can create a topic. I can give it my, let's say, my SNS topic, okay? This is the display name, right? I can give it a display name, it's optional. I just can encrypt it if I want to, enable encryption, access policy. I can have a basic or advanced. This is an example of the policy. It's in JSON, like I said before. All policies in AWS are in JSON. Who can publish this? Only the topic owner, only me, or everyone, or only specify accounts. Okay, you can put the accounts here. All right. In this case, I just put it here. Who can subscribe to this topic? Only the topic owner is the one that can send the subscription. Everyone can subscribe to the that, or only specify accounts, or only requesters with certain endpoints. Deliver retry, just in case you want to retry that 3 times, right? Okay, the minimum delay is 20 seconds, maximum delay is 20 seconds. Configurations, right? You can use the default one, or you can just simply, you know, tweak them the way you want. I'm gonna use the default ones. Deliver status, optional, right? Logging, right? You can have a Lambda deliver that to CloudWatch or S3. You know, I don't want that. A role, if I have a role, tags if I need tags, and then I create a topic. Right. So I have a topic now. What I have to do now is create a subscription. Someone that will receive the messages from SNS. Okay, so I can either do it through HTTP, then I have to put the website, right? The URL, right? HTTPS, I have to do the same, but instead of being HTTP, HTTPS. Or I can do an email, right? I put my email. I can put email JSON, right? JSON format. I can put the queue, right? I can put Lambda, platform application, SMS, just in case it's mobile. You want to send a text message. Okay, so in this case, let me try email JSON. Right? Let me see how it goes. So I can put my email. Okay. And then I create subscription. Right now it's in the pending status. It says pending confirmation, right? What I have to do is just come to my email, right? So I can come to my email now, and then I can put my password here. I'm glad that it's not visible. Okay. So I have a subscription here that I need to come to. And then I have the subscription here from AWS. So what I have to do, you see, JSON. You see how it came in JSON format? You see? Key value. So what I have to do is just
Can you reformat that into with HTML to look more digestible?
HTML, you have to provide URL. I don't have a URL for that. It's pretty weird, right? If you choose email only, I'm gonna choose email only. Okay. Let me see. It should be this one. Okay. I don't even know how I accept this. This is so weird. Okay.
That is
so what I have to do is just go back. Go back and create another topic with. Can I edit this? Let me see. I don't think I can. Let me see. Let me see if I can. It's my SNS topic, right? I think I edited. One more. I can
delivery. This is
delivery try. I don't think I can. No, I cannot change the way it is delivered. I cannot change that. I think it's subscription probably. Let me see. My God. Okay, let me see. My SNS. My SNS.
right there.
Oh, it's not gonna show. It's not gonna show because I haven't subscribed yet.
Is the one that says email JSON?
No, I haven't. Well, actually, that is yes. Let me see if I can. I can edit. Sorry, I didn't see it. Let me see if I can edit that. No, I cannot edit that. So we have to create another one. Let me create another one real quick. So let me see here. Create topic. That's it. I don't need anything else. So now I'm gonna create a subscription, and I'm gonna create a subscription here, and I'm gonna call it. I'm gonna call it. Where's this one here, right? Yes. So I'm gonna receive an email, right? And then I'm gonna put Dunia skill down. Now it's gonna be a little more readable, but it's not that readable yet. All right? Because I don't know why these have this weird thing. You see? Now if I have this here, you see, still, it's a little, I mean, I don't know why this one came this, because I have had some other that are really complicated to read, especially when you get a notification. So if I subscribe now, boom, this is better. So at least you have a link, but with the other one, I mean, I click on this one, and it gave me deny access, right? Okay. It's even less readable, right? I think that this is a confirmation, right? But it gives it to me in XML. That's the extensible markup language. There's another type of language that has tags too, like XML, like HTML, but it's more difficult. People don't use this anymore. I mean, people still use it, but they use JSON more than this. Okay.
Yeah, they use XML for. For
yeah, but people prefer. I mean, once JSON came, I mean, people are using JSON more. This is more complicated. Still, there's some technologies that use XML. Okay, but you know, it's more complicated. But then we saw to create a topic, and then we subscribe to the topic, and then you can have a email. These guys that I show you, you know, and we selected email, right? Plain email, not JSON. You single published a message. Order is not guaranteed or relevant. Order doesn't matter. No recall. There's no recall for this one. It has HTTP, HTTPS retry. You can retry it. And the maximum, as well as, I mean, the same as SQS is 256 kilobytes. Don't forget that. Okay. Very important. Okay, guys, it's 2:29. I think it's time for a short break. Let's take a 10 minutes break and be back at 2:40. Okay. It's 2:40. We're back here.
Yes, sir.
So I'm gonna post a poll for you guys to answer the questions. So you should see it now in a moment. All right. You see it?
Yes.
Yes.
Just one moment, student. One moment. Just one moment. I'm gonna relaunch it again. Just give me 1 second, please. Give me 1 second. I'll launch it again later. Okay. So let's continue for now. So, one moment. Okay, so SNS and SQS comparison. Amazon SQS and SNS are both messaging services with AWS. Message persistence, SNS is not persistent. The message is sent and that's it, right? Amazon SQS, the message is sent, the message process goes back to the queue. If it is not processed, if it is processed, deleted, but it can be saved in a queue, in a dequeue letter, just in case it's not processed, so it's more persistent. The delivery mechanism is push for SNS, right? It's passive. You just create the topic and the subscription, and that's it. It will be sent. The poll is active for SQS because it's constantly pulling the messages from the queue, the consumers. The producer publishes and the consumer subscribes. That's for SNS. That's what we did a few minutes ago, like 10 minutes ago, right? And Amazon SQS, it sends the message and then it's received by someone else. Okay. Another component. Distributed model is one-to-many. You can have one message sent to multiple subscribers. And in the case of SNS, it's 1-per-1. It's only one component will process a message. It's one component per message, right? Okay. Fan out is, like I said before, is when they work together. You know, you have a notification the image has been uploaded. You get an SNS topic, and then the SNS topic is sent to a queue, several queues, and then one queue will generate the thumbnail. Another queue will size the image for mobile, and another queue will size it for web. Okay, so you can have these guys working together, and that's what is called fan out. SNS and SQS working together. Okay. So end-to-end scenario. So we have here a CrowdFront distribution download here. You know, the user is just downloading some information from S3. Okay, and then but first the user uploads the image in an S3 bucket for ingestion, right? This triggers notification, SNS, right here. Okay, we can see that if I go to if I go through here, and if I go to here, an S3 bucket, and then it's the S3 bucket, I have something here that I can go to the properties, and then in the properties, I can have something called events right here, and then I can add a notification. And when someone puts post or copy file, I can have sent to a SNS topic, and I can choose of the ones that I just created. The one I just created, I can select to here, and then I can just you know, send the notification, right? Like my email event, something like that, and then I can save it, right? Oh, let me choose a destination topic. Do not allow S3 to publish notifications from this bucket. Okay, so I need a policy for that, right? I need a policy that allows S3 to send messages, right? It doesn't allow S3 to publish notification from this bucket. Okay, so I need a policy for that. I don't have that policy in place, but guys, this is basically, you have an event here, right? You have an event that triggers an SNS topic, right? Event notification. And then with event, I can just, using this fan out analogy, I can notify to 3 queues, right? And they will process this, right? The generate thumbnail, size for mobile, size for this. Okay, I don't see a Lambda function here. The Lambda function is the one that does this. Well, I have an instance here, okay? Usually what is used is a Lambda function, but in this case we have 3 auto scaling groups, right? 3 instances are generating the thumbnail. 3 instances are sizing this for web, and 3 instances are sizing for mobile, right? Now, this is for server full architectures. If you're using a serverless, then you're gonna use 3 Lambda functions. 1 Lambda function will do 1 action here, okay? Then after that, this is placed again in an S3 bucket, right? Already the thumbnail, the image resize for mobile and web, and then Amazon S3 bucket is gonna serve the content to CloudFront, right? And CloudFront is gonna distribute that content globally, so the customer can download that image, right? So it's a pretty good process where I just upload a picture, any picture, right? And then behind the scenes, whatever company created this structure here, because the user has nothing to do with this. The user just uploads the image, right? And then behind the scene, this company, whatever company did this, whatever architect did this, he created this architecture that whenever someone uploads a picture, there's going to be 9 instances working on that picture. 3 instances for this, 3 for this, 3 for this. Then that that picture already worked in different ways, thumbnail and these different sizes, is going to place back into the S3 bucket, and then through a URL, this user can download the picture. Okay, it's pretty good, right? It's pretty good. This is mainly for any website where you can upload and resize images. This is what happens in the backend. Okay? So microservices example. Well, we spoke about this already, but this is another graphic that you can take a look at. So you have the monolithic application. So you have the users that use this uniform one product thing here. Okay, one thing here that has 3 instances that can file, ingest, process, and publish. Okay, all of the same thing does the same thing, you know, all of that. But in microservices, look at the difference. It's more loosely coupled than this, right? So we have a user that, you know, sends a file here, you know, and then the file is sent to put into a message, right? And then it's ready for processing in the queue. This entire process, it goes to the file processing section, right? Now, the file is processed and pushed into a bucket. And then the user is given access to publish that file. All right. So at the same time, the user receives a message using SNS, right? That the process has been complete. Okay. And the user originally subscribed to this topic. Okay. So this is high level an explanation of how microservices work in this architecture, where SNS and SQS work together to deliver a better user experience in this architecture. Here is a little more prone to fail, because everything is working together here uniformly in one single section here. Okay, stylic couple right here. Amazon MQ, that's a service that AWS has. Okay. MQ is a managed message broker service for Apache Active MQ. This is something that many companies use, that makes it easy to set up and operate message brokers in the cloud. Message brokers allow different software systems, often using different programming languages and on different platforms, to communicate and exchange information. Amazon MQ reduces your operational load by managing the provisioning, setup, and maintenance of the Active MQ, a popular open source message broker. Okay, so that's what Active MQ is. It's a popular open source message broker. Connecting your current applications to Amazon MQ is easy because it uses industry standard APIs and protocols for messaging, including JMS, NMS, MAQP, STUMP, MAQTT, MQTT, and WebSocket. Using standard means that in most cases, there's no need to rewrite any messages code when you migrate to AWS. So basically, This guy works with ActiveMQ, which is an open source message broker. And if you want to know more about it, there's some features here that you can read about that. It's a managed service. It has high throughput, high availability, and message durability, and secure. It's monitored broker instance types. Okay. This is not, as far as I know, is not that important for this exam. Never saw it in an exam. Never seen it in a practice exam, but at least you should know that it's part of the decoupling portion of AWS. Okay, that's all you need to know. You don't have to sweat on this. This is not that important. It's just information that you need to have. If you want to know more about this, you're free to just be free to research on that. Okay, so it's set up and operate message workflows in the cloud, automatically provision for high availability. It's native high available. Okay, you don't have to do anything. In the AWS, you have services that you don't have to do anything about high availability because they're native. They have native HA. But there are others that you need to work on that, like EC2. You have to create auto scaling, RDS, multi-AZ, things like that. Okay. It provides direct access to ActiveMQ console. Okay, you can have that access to the open source message broker. Supports a variety of messaging technologies like this, the one that we just read about, these guys here. No need to rewrite your existing message code. It's exactly what it says here when we just read the overview. There's no need to rewrite any messaging code when you migrate to the cloud. So probably in your infrastructure on premises, you have something that you wrote here, but AWS has all the capability to receive this migration, and you don't need to rewrite anything again. So the message payloads is up to 32 megabytes. For SNS and SQS, it was 256 kilobytes. Here's up to 32 megabytes. So as you can see, it supports more or a bigger payload. JMS, local and distributed XA transaction support. This is more advanced, okay. The 7 nines of message durability, okay. I understand that 11 nines is once in 10,000 years. 7 nines, I guess, is, I don't know what to tell you. It's just, a comparison that someone came up with for the 11 nines. I haven't heard anyone commenting on this. Probably, guys, if you do some research, probably find someone and they'll give you an equivalent of what 7 nines mean when it comes to time. All right. No upfront investment, no minimum fee, pay as you go for messaging instance as usage, storage use. Free tier includes 750 hours on an MQ T2 Micro. As you can see, T2 Micro is always for the free tier, and it's very, so far we've seen that it's very smartly named because you have EC2 instance is T2 Micro, right? Database in T2 Micro is db.t2micro. And then MQ is nq.t2 micro. So it's very smartly named the way they do here, using like something before T2 Micro to identify the service that we're talking about. All right. The free tier includes 1 gigabyte of storage per month for a year. I think that if you're just playing with this in the console, you don't have to worry about storage because I don't believe you're gonna store massive data there, or you're gonna run it for more than 750 hours. Okay. So we have all the decoupling services like Amazon DynamoDB, Amazon API Gateway, and AWS Lambda. By the way, these are one of the pillars of serverless, okay? These guys are gonna be in every single serverless architecture, these 3 guys. along with SQS and SNS. So they're going to be, there's like the three musketeers here. All right. So DynamoDB is a great solution for storing and retrieving your processing output with high throughput. Okay. So DynamoDB is highly available, fault tolerant, fully managed. I believe that this sounds like something familiar for the morning class. Okay. So, sorry?
No, I said yes, sorry.
Yes. So loosely coupled systems can work very well with a managed NoSQL database solution like DynamoDB. DynamoDB is NoSQL. Don't forget that. It's NoSQL. Okay. Good. So an example of mobile voting platform. Okay. People are voting and using a mobile application. So the client votes, right? And then the workers, the queue, and then the workers, the guy is processing the queue, right? Then valid votes, and you have invalid votes. Okay. So these guys probably are placed in a dead letter queue, okay, because they're invalid votes. And then the valid votes would be displayed here in the web dashboard, right? And then the users can see the valid votes. Okay. I believe that these users are probably the people working for the votes, right? Because if I vote for a president, right, in an election, during election period, I'm not gonna know who vote for someone. I don't know. I probably just they tell me how many votes a specific candidate had and how many votes another candidate had. The two presidents, the people who were running for office. So you're gonna know how many, right? But you're gonna know that you're not gonna see the names, right? Okay. The people working with the, is that what you call it? The ballots? Is that what they call it? The people working with the counting and all that, and we're seeing this. I don't think they're gonna know the names either because usually voting is anonymous. But they can see that at least they can have an overview of the voting section in this dashboard, right? Because this DynamoDB, they had the valid votes here, and there's no valid votes here. So if you're using SQS, right, for this decoupling thing, then when you put this probably in a queue here. But we're using DynamoDB together with SQS. So SQS is going to be before you do anything. So the vote is going to be here in this queue. Then the worker is going to do this during the visibility timeout right here. And then the valid votes are going to be placed in a table that there is named valid votes. And then the valid votes are going to be in another table. You're decoupling this, putting this in one table and putting this in another table. And then the process goes on, all right? But this is how you use, this is one of scenarios of how you use DynamoDB with SQS, all right? There's a whole beautiful world happening behind the scenes that we don't see when we see a web application or something. There's so many things happening in the back end that we don't see. It's I guess it's marvelous. It's marvelous. It's I don't know. It's awesome, right? And just people just take it for granted and they just vote and that's it. I voted. All right. But if you analyze what's happening behind the scenes, how the voting system works, oh, that's amazing, man. You see, there's smart people behind this. There's really smart people behind this. Okay, so we have a case study, Tokyo Hens. So for a few $100s a month, we get a fast, highly available, and scalable database We don't need to spend any money on expensive hardware or personnel to operate the database, simply because we don't have to manage any servers, right? We don't have to manage any servers. We are on the cloud, and we don't have to do anything with hardware for our infrastructure. It's all on Amazon AWS, right? And when it says for a few $100, so it's very cheap. So the challenge, Tokyo Hands operates 40 physical stores across Japan and Singapore, and an online store worldwide, offering an enormous variety of crafting items for purchase. Prior to AWS, this is when they were in trouble. Prior to AWS, their IT systems were located in an on-premises data center, which struggled to scale with spikes in traffic, particularly with their point-of-sale POS system. Right? During their 2012 to 2013 Hands Messy sales events, service interruptions due to their overloaded backend led to a direct loss of revenue. Of course, if your service is down and you have a very good product that you're selling, you're going to lose tons of money because you're not going to be selling, right? And you have so many customers, trying to purchase and they can't, right? And I'm not a psychology expert, but I don't think that it's when this happens, nothing positive is going through the minds of the buyers, of the customers. All right. So some people are not patient enough and they just quit and go and don't purchase anything. And they might come back a later time. Okay. But maybe it's out of that, peak spike in traffic or thing, and then you're gonna have only one sale, I'm probably the person that never comes back, because they say, okay, I'm gonna go and probably purchase this, crafty items from another vendor and not these guys, because their website simply sucks. So I don't want to deal with these people. All right. So solution, DynamoDB. In just a few months, Tokyo has built a brand new POS, a point of sale, a merchandising system around Amazon DynamoDB. The solution also used Amazon S3, Amazon SQS, and Amazon SNS, and was hosted entirely in AWS. Using all of this managed solution together, Tokyo Hands to scale easily with the demand, with little need to worry about component failures. So now this is what they say. AWS offers a wide variety of fully managed services that makes it easy for us to architect our entire IT system. Amazon DynamoDB is one such service that is at the core of critical applications. It scales automatically. Okay, it has the speed of the single digit milliseconds, super fast. And they don't mention anything here about EC2 instances. Do you see it? EC2 instances? I don't see it anywhere. No EC2 instances, right? Which tells me that they might probably have gone with the serviceless architecture, because they're using S3 serviceless. They're using DynamoDB serviceless. They're using SQS serviceless. They're using SNS serviceless. I don't doubt they're using probably API gateway. I don't see it here, but they work together with Lambda and DynamoDB. I don't doubt, I might think that they're using Lambda as well. If they're not using Amazon EC2 instances, they're using Lambda, right? So I think that they just probably chose to go smart and not use any servers. All right. Not sure about that because they don't mention anything about service here, but I might think that probably they chose to go serviceless. Not sure. So most of our teams, a team is made up of former clerks of our retail store They know our customers in and out, and we want them to use that knowledge to build powerful applications and not worry about infrastructure. So we're not worried about infrastructure. So it probably means that we are not worrying about any servers, right? So we want to focus on customers, okay? With AWS, we are able to do just that. Now the benefits: using a multi-AZ architecture with DynamoDB, Tokyo Hands 2014 has so endured that, you know, the years before 2012, 2013, they were struggling. They were just in big trouble. Now in 14, the sale and ensured their tables were highly available. Quickly scaling the throughput of their tables prior to the sale meant that, unlike in 2012 and 13, none of the database requests were rejected due to capacity restraints. So we were unlimited. We were able to scale as much as was needed. And now we don't have to worry about any limits. We don't have any limits, okay? So on the self-finish, Tokyo Hands scale its throughput capacity back down to save money. So during this peak traffic, you know, this high traffic and a specific certain day or period of time, we were able to scale out and be able to cope with the whole traffic. But now that everything is just finished, we just finished this period of the year. Now we can just shrink and go back to what we were and save money. We don't have to use all that capacity that was needed for the entire peak. Now we can come back and simply continue our operations as normal, okay? Which is pretty good with AWS. You know, it's tons of benefits. I don't know why. I have no idea why. I can think of a reason why a business owner would neglect AWS. I have no idea what, to be honest. Okay, you don't have to give it all up. You just can have a hybrid architecture, right? But there's some people that are so skeptical that they don't even want to have a hybrid infrastructure. They don't want anyone else to manage their infrastructure. So they want to do it all from the on-premises. But, you know, it depends. It depends on the use case. It depends on the company. So if your company is local, you might not need the cloud. You know, it depends, right? So Amazon API Gateway. Amazon API Gateway, it's one of the pillars for serverless. Don't forget that. Allows you to create APIs that act as front door for your applications to access data, business logic, or functionalities from your backend services. It's fully managed and handles all tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls. Can handle workloads running on Amazon EC2, AWS Lambda, any web application. So it can either work with servers and with serverless architectures like Lambda, for example. So if you come here to the console and you just put API Gateway, right? So we can create an API. I have several APIs here that I've created in the past, you know, that have a get, method here. When you see, you can test this. I can test it and then test, and there's no data, okay? You have several APIs here. Okay, so I can create an API, right? And I can make it WebSocket API, HTTP API, REST API. And just gonna do here, HTTP. I can add an integration here with a Lambda function if I want to, right? I can give it an API name, okay? It's gonna go, let's call it my name, okay? So I can integrate this with Lambda. I don't have any Lambda function, maybe this one. Okay, and whatever this function is doing is going to be connected with the API gateway. And what is an API gateway? It's just like a door, okay? Like a door that opens for APIs to connect to your infrastructure. So I can do this, and then next, and you know, this is, don't worry what I'm doing here. It's just to show you how it works. So I have an API gateway here, and then I can deploy it, but I'm going to deploy now. So I could come here and maybe have stages here, course, custom domain names, okay. So I can create here, this is a demo one. I can create here just to create a method, and just create here probably a post, or maybe I already have a get. Maybe I can post something, you know, and I can use a Lambda function for that. I can have some Lambda proxy integration. Request will be a proxy to Lambda with request details available in the event of your handler function. That's for the function of the Lambda. Right now I can put this one and then save it. It's just a post thing, right? I don't have any Lambda function working for this, okay? But you can have several methods here. You can have create a resource, right? A resource, for example, let's say that you have a website that, for example, let's say my resource name, probably the ID, right? And then you're getting the ID from that particular URL. You know, it's just, I don't want to confuse you guys, just to give you an idea how API Gateway works. So it just integrates with Lambda and DynamoDB and all those guys to work, and just create that. And then once you're done, right, you can enable CORS, right? Because it's cross-origin resource thing here, sharing. And then you can just put the origin here that anything can connect to my API gateway. Okay. Because probably, you know, the browser doesn't recognize that, and it's gonna, it has the, if the cores are blocked, and then you're not gonna be able to access the resources. So you have to enable cross-origin resource sharing, so the different origins can share resources, right? So once you're done, you can deploy your API gateway, okay? Every time you make a change, you have to deploy your API gateway, okay? So what else do we have here? Deploy, let me see. Resource dashboard. So we have some monitoring here, monitoring, API calls, latency, integration latency, 400 error, 500 errors, settings, API keys, client certificates, usage plans, stages. We can have here def and prod. I create all this, right? Def and prod. You can create another one if you want to. You can create another one to call it test. And then we have another maybe deployment here. Create. And here I don't know if I mentioned this before, guys, but this is the canary or canary deployment. Canary deployment where you can deploy a certain percentage. For example, I want to deploy 10% first to the new environment, and the 90% I'm going to deploy them later, right? So you can do this with either API Gateway. You can do this with code pipeline. You can do this with Elastic Beanstalk. So if I click here, there's nothing because I don't have anything to show, right? But this is when you invoke. This is invoke that you when you invoke the API Gateway. Okay, you know this is where all these integrations are going to come into place. Or whatever you have in Lambda, or whatever you're going to display, you're going to click on this, and then it's going to be deployed. Now, if you have several deployment environments and you're using Canary, you know that in the back end, only 10% of the traffic is going to go to the green environment, which is the new one, and the other remaining 90% is going to be running in the blue environment. So we have a blue-green deployment. Now, this is when you want to switch to another environment. Okay, then you will use this canary deployment strategy, because maybe you're not sure that this new environment, the green one, is ready to receive all the traffic. So you just send the 10% there, and then after 10 minutes, for example, to 10 minutes, you can choose to send the remaining 90%. Okay. A little, high level overview of API Gateway. All right. You don't have to be an expert in that. Just know that they are used to host and use multiple versions of stages of your APIs. Okay. You create and distribute API keys to developers. They're here. API keys, okay, to developers, right? Create API keys, right? This is like authentication for them, right? You can use some API keys and then you give it to them, they can work with this. Leverage signatures version 4 to authorize access to APIs. Version 4 level signature is here in the authorizers. This is for authentication, right? This is for authentication, very important. If you want to restrict the access to your API Gateway, then you will use authorizers and all that, signature. Throttle and monitor requests to protect your backend. So there's some monitoring here. Where you can have some, idea of how your API is performing, API Gateway is performing. Okay. So it's integrated with the AWS marketplace. So probably if you come here, I don't know, maybe. Never tried that before, but I'm gonna try with you guys. So if I launch this here, probably, if you come to the marketplace and then you put API. No, I don't think that this is a place for this. Not the place for this. So with the marketplace, you would need a subscription, right? Okay. Okay. To see available subscription, visit Discover Products. Okay. We have some API things here. PIGaway, Fortinet managed rules, or these guys here. But you know, you have to pay for this. So if I go, just go to the default one, Microsoft Windows Server 2019 base. This is not free, guys. This is an optimized one for ECS, yeah, for Elastic Container Service. Okay, look at this. It's super cheap, right? Right? This is 96 cents an hour, right? So, no, oh, this is less than 96 cents. Right, so
That's
So-
less than one, no,
Huh?
it's 9 cents.
yeah, it's 9.6 cents. Yeah. So this is not free. Right? So it isn't a free tier, right? But after 12 hours, after 12 months, because this is ACS optimized. This is heavy duty. Okay. But you know, what I'm telling you is, guys, is that it is integrated with the AWS marketplace. Right? So AWS also has a marketplace where they sell things. Okay? Even they have, when you have your certification, right? Oh, what is this? Oh, Chinese. Okay, so oh my God. Okay. So come here. And then so I can have here, what are the benefits for the store? I don't see a benefits, but usually they show here benefits for the store. By the way, they have a new way of showing the badges. This is the old way, right? Which, by the way, is very big. When you put in your LinkedIn account, it's super, super, super big. People cannot see better. But I already migrated to a new one. I already updated mine. So when you come to LinkedIn and you see my profile, okay. I have so many messages here, it's crazy. The new one, you can see it very well. All right. So you can put it here, all right? And when you click on it, it doesn't go to the AWS section. It goes to the acclaim section, okay? Acclaim. So you can see all the information you want to verify, then you come here and it's verified. But the way it was before, is what I have in my, when I list my certifications. This is how it was before. Right? It was before like this, but right now it's different. Okay. Well, just extra information for you guys. Right? So Continue. Benefits of Amazon API Gateway. It managed cache to store API responses. So there's some caching for that. Reduce latency and distributed denial of service DDoS protection through Amazon CloudFront. Amazon CloudFront is the one that is before you get to the API Gateway. You have Amazon CloudFront. Amazon CloudFront has ways to counteract or counterattack or strike back DDoS attacks. You also have Shield. Shield is another one. Shield that has a basic shield and a standard shield and advanced shield is for DDoS attacks. I also have CloudFront that's going to help with that. All right. So SDK generation of iOS, Android, and JavaScript. So software developer kits. Open API specification for Swagger support. Do you guys know what Swagger is?
No.
No Swagger? Okay, Swagger is a technology to test your API calls. Very, very useful for full stack development. Okay. All right. So let's say that you want to. So let's say that your store is called My Store, for example. So you have https://www.mystore, right? Let's say that you want to bring a specific order number from the database. So you put https www.mystore/04576. That's the order number, right? So that's gonna bring the information of that particular order. If you want to test that, you can use Swagger for that. So you can put exactly the same thing, and it's gonna work like that. If you want to test your HTTP methods like post, copy, or delete, or patch, all those guys, you can use Swagger for that. So Swagger is a very good third-party technology for full stack development. Okay, serverless architecture. This is the good part. Okay, serverless. I prefer to go serverless, but not everybody likes that. So we have the Amazon SDK, so we have access to this. Okay. So we have Amazon S3. This is the guy, the DNS resolution, right? This is the guy that we type just the domain, and this is the guy that translates into IP address. So we come here to the API gateway, right? And there's some section here where you cache that information just in case when you go back again and request the same information, this guy doesn't have to do the whole thing again. It just comes here and picks the information from here and say deliver it to the users. As simple as that. Okay, that is what the cache is for. Okay, so Amazon API Gateway is integrated with a Lambda function, and the Lambda function is integrated with these services here. This is DynamoDB. This is S3. This is SNS, right? SNS, I think it is. I'm not quite sure, but the names based on their on the icon. Okay, they have changed these icons a little bit sometimes. Okay. Okay, Cloud Search, good. Thank you, Christopher. And SQS, right? SQS and Cloud Search. Very good, good. Thank you, thank you. So it integrates with these guys, and you have Amazon S3, right? Okay. And then you can just have your study website here in Amazon S3. Okay. So you have either ways. You can go through this route here, right? Or you can simply just write the URL in your browser and get your website from here, like this. Okay, like this. Okay, this is all hosted in an S3 bucket. All right, Brian. One day we want to see your website, how it's coming along. All right, because I hear you're doing your website using S3 bucket. Probably you can walk us through of what you're doing, and then you can share with the class how you accomplish that. Right. So when do you think you're going to be done with this? You're still in the process? Oof. Okay. Okay. No problem. Maybe one day we can probably dedicate 5 minutes for you to walk us through what you have done. Maybe. Yes. Probably. Olivera, you raised your hand. You want to say something?
Accidentally, I'm sorry.
Yes.
I put it accidentally, sorry.
You put what?
I accidentally pressed the
Oh,
hand.
okay.
I'm sorry.
Not a problem. Yeah. So now serviceless architectures, we have decoupling here. Infrastructure, Lambda is a great solution for processing data with high availability and a limited cost footprint. Okay. AWS Lambda allows you to further decouple your infrastructure by replacing traditional servers with simple microprocesses. Okay. We are just removing the servers. That's why people are opting in for this great service right now, Lambda, and just putting aside servers because they want to, has less overhead and focus on something else rather than servers. So AWS Lambda, you run the code without provisioning or managing servers, pay only for the compute time consumed, no charge when your code is not running, set up your code to automatically trigger from AWS services, call it directly from any web server or land a mobile application integrated with AWS Marketplace. Lambda starts with code with milliseconds of events such as image upload, in-app activity, a website click, output from a connected device. Consider AWS Lambda if you're using entire instances to run simple functions or processing applications. You don't want to worry about HA, scaling, deployment, or management because HA is native in Lambda. Okay, you don't have to worry about that with Lambda. This is the advantages of having Lambda over EC2 instances, that you don't have to worry about any of this, right? Any of this. EC2 instances, you have to work on HA, you have to work on scaling, you have to work on deployment, you have to manage it some way, somehow. With Lambda, you don't have to do anything. You just upload your code, run your code, and that's it. Simple, 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 simple. Nothing else. Okay. So these are the guys that trigger Lambda. Okay, so we have Amazon DynamoDB, Amazon S3, Amazon SNS, Amazon Kinesis, Amazon SES, AWS Config, Amazon Cognito, AWS SDKs via Amazon API Gateway, Amazon CloudWatch, AWS Code Commit, AWS CloudFormation, Amazon Echo Alexa Skills. All right, you can even create Alexa skills with Amazon. I created one a while ago. I created some romantic tests for my wife. My wife told Alexa, what can you tell me about Dunieski and Janet? Oh, I said Alexa, and Alexa responded. You see, it's in the background talking.
Alexa, my Alexa responded.
Nice. Okay, so
that's a good one.
so if I say, Alexa, what time is it? Probably responds. Mine's is 3:40. All right, so, and then
Are you gonna go into more detail about Amazon Cognito?
we might not. We might not because this is more for developers.
Okay.
Okay. So my wife says, tell me something about Dunieski and Janet, and then it gives her like Dunieski and Janet met 4 years ago, like that. And Alessa gave her like a short story of us. Pretty good. You can do that in the developer section of Alexa. Anyone can do that. Okay? Just need an account and Alexa. That's it. Resource sizing with AWS Lambda. AWS Lambda currently offers 46 levels of resource allocations, which range from 128 megabytes of memory and the lowest CPU power to 3G of memory and the highest CPU power. Okay, so something that you have to know is that in Lambda, the more memory you use, the more CPUs you would need. Okay, so these guys are going to be directly proportionate. Okay, so the more memory you allocate, the more CPU you're going to need. Right, very important to know that. More resources, lower latency for CPU intensive workloads. Compute price scales with resource levels. And function can run between 100 milliseconds and 5 minutes in length. This is not updated. Okay, guys, this is not updated. Okay, this is what this was before. And I'm impressed that I overlooked this. Okay, so right now it's not 5 minutes, it's 50 minutes, right? So Lambda function can run up to 50 minutes in length. Okay, free tier is 1 million free requests and 400,000 gigabits per second every month of compute time. Okay, that's what the free tier includes. Okay, how do you work with Lambda? You upload your code to AWS Lambda. It has to be zipped, zipped, or you can write the code yourself in the Lambda console, right? But you can upload it. You can also write your code directly into an editor in the console or import it from an Amazon S3 bucket. So 3 ways to have the code in Lambda. One is uploading it in a zip file, or you can write it yourself, or you can import it from an S3 bucket. You can schedule a function, specify how often it will run, event-driven function, identify the event source, specify its necessary compute resources. The memory goes from 128 megabytes to 3 gigabytes of memory. So the higher the memory, the more CPU you will need. Specify its timeout period. Specify the VPC it needs to access if applicable. Okay, it's not a VPC-based resource, but if it is applicable, you can put it inside a VPC.
What is the timeout period in this scenario?
And which one?
What is timeout period?
Oh,
in this scenario.
The time that will get to run. Okay, if it is 6 minutes and your application needs 7, it will time out. That's the time that will be executing your application. The longest it can execute is 15 minutes. If your application needs more than 15 minutes, you cannot use a Lambda function. Every execution has to be less than 15 minutes, but you're the one that chooses the time. I will do that now. I will give a demonstration of Lambda. Okay, and then you just launch the function. That's it. From there, AWS deploys it and manages it for you. So we have AWS Lambda as a web server. So we have here browser requests, website for CloudFront. So we have the CloudFront caches the site at an edge location. Don't forget that. CloudFront retrieves the site from Amazon S3 if necessary. And then website HTML hosted in Amazon S3. This is the way if we want to go this route, okay? Using the URL and all that from just like the one that I show you and the one that Brian is building this way. but you can go this way. All right, so connect to a Lambda function. A Lambda function pushes the notification to Amazon SNS, right? And do that with the API gateway. But this is how Lambda works in conjunction with all these guys together. Okay, so Lambda function will push the notifications. The notification will be sent to the subscribers, and then Amazon DynaDB is going to store whatever information needs to be stored, right? But all these guys working together, and Lambda working as a server. But don't forget the Lambda is serverless, but it's working as a server. Like imagine that you have an EC2 instance here, right? So Lambda is doing the job of a server, which by the way, is not a server. So don't forget that. All right. Typical data processing solution. So we have a data source here. Okay. So we have some servers polling for work, starting jobs, additional servers performing load balancing, just servers just push jobs to the queue, right? And we have a backup failover site just in case. So servers polling the data. This guy is polling the data from the changes to the data. Oh my God. So we have a queue here. Okay. The servers working with the the queue. They put the data in the database, and then they're working here with the queue. And if something happens, like I said before, they will fail over to this site here, which is usually a static website. Okay. Data processing with Lambda. Okay. In this case, we have servers, right? It's right here. With Lambda, we have Lambda here with data source. Data source can be what? S3. It can be your text editor. It can be you uploading the data, right? You put in data, and that's and Lambda, and that's it. Done. So AWS Lambda handles the listening and the polling, the queuing, the processing, the automatic scaling, redundancy, load balancing. Lambda does everything for you. What you have to do simply is put the code in Lambda. That's it. Lambda will do the rest. And how convenient is that? How convenient is that? It's super, super, super convenient. And the good thing about this, the beauty of this is that Lambda will not incur any charges when it's not running. So that's a good thing, right? So we have some decoupling examples here. HTTPS request survey website, right? Customers. Amazon S3 server serves secure HTML survey page. Then it makes an AJAX call. AJAX is asynchronous JavaScript and XML call, right? And then it connects to the API gateway. The API gateway triggers a Lambda function, right? And then the Lambda function will put the results encrypted in an Amazon S3 bucket, right? And the unencrypted server metadata with no personally identifiable information. So no social security number or any things that compromises the identity of that person, will put it in a table. Okay, so this, whatever is important, will be placed here with server-side encryption, right? Using advanced encryption standards, 256, right? And also at the same time, when you get here to the API gateway, you're gonna put the logs in CloudTrail. CloudTrail is the guy that's gonna record every single API call that happens throughout the process, right? It's gonna tell you, hey, who made this API AJAX call? What triggered the event? What information was stored here, and when it was stored, and who stored this? Who configured this Lambda function? Okay, what information is stored here? So this guy is super important for governance, auditing, compliance, everything. CloudTrail, okay? Processing Amazon CloudWatch logs. So you have Amazon CloudWatch logs. You have an AWS Lambda function that is triggered, and then you're gonna put them either here in a table, Amazon TB, which is NoSQL data store, or maybe you wanna put it in a durable file store, which is in S3 bucket, or maybe you wanna bring it to Amazon Redshift for data analytics, right? We haven't seen this guy here because I was seen in the morning, right? But this guy is used for data analytics for BI tools, for business intelligence, right? And it works with nodes, right? A little node. So you can have those logs for processing for analytics here. You can have them to be there and in a durable way, because that S3 bucket has, or S3 has 11.9 durability, or maybe you can put it in an Amazon DynamoDB table. So different ways. It all depends on your needs, whatever choices you want to go for. So AWS Lambda message handling. So we have here Amazon SNS, AWS Lambda function is triggered by this. And then, you have a topic here. You push a notification, right? Or you can use Amazon Kinesis for high throughput stream handling. Kinesis is used for real-time processing, right? Things that are happening, in real time. More advanced service for developers and DevOps certification, okay? But what you have to know is that Kinesis has Kinesis Firehose. The Kinesis Firehose, what it does is puts the information in an S3 bucket. Kinesis, everything that comes through Kinesis, if you want to put that in an S3 bucket, you have to use Kinesis Firehose. And you also have Kinesis Analytics, and you have Kinesis Streams. So this is for real-time processing, right? And CRUD, CRUD, backend workflow, CRUD, CRUD is create, read, update, and delete, the CRUD operation, right? Create, read, update, and delete, backend workflow. So we have Amazon API Gateway, right? And it works with a Lambda function. And then the Lambda function, what it does is put the information in a DynamoDB table, which is an NoSQL, or an S3 bucket to make it durable. Okay, so we're seeing a lot of integrations here. Okay, so seeing Amazon CloudWatch working in conjunction with Lambda functions, SNS working in conjunction with Lambda functions, API Gateway in conjunction with Lambda functions, SQS here working in conjunction with servers and Lambda functions, all that. It's super amazing how many integrations you can have with AWS services, and especially the serverless architectures. So today what we did was review the meaning of loose coupling, identify several loose coupling strategies, gain an understanding of how to communicate easily and reliably between components and with DynamoDB, discuss how Amazon API Gateway can be used for loose coupling, explored serverless architectures to understand their ability to provide loosely coupled, fully managed compute services, and review several decoupling examples. Today, there's no labs. Okay, yes, we do. We have lab 7. Okay, lab 7. Do you have any other questions, guys? No questions?
Lab 7 or lab 6?
Lab 6? Lab 6. Let me see. Let me see one moment.
I think it's 6.
Let me check. Well, actually 7. Implementing a serverless architecture. There's no lab 6 in this class.
Okay.
Okay. Remember, labs are not in a sequence. Okay. There's no lab 6 here. So lab 7 is going to be your due. It's going to be due probably tomorrow.
So this is standard SQS,
Standard SQS.
no sequence.
Oh. Okay. Got it. Okay, guys. If you don't have any questions, I would like to probably give a demonstration on how to schedule a Lambda job, probably in conjunction with CloudWatch. Let me see something here. Okay, this is a Lambda function that you can use to, guys, this is a Lambda function that you can use for, maybe you want to see that. A Lambda function that you can use to bring all the buckets. Okay. So maybe you can copy it and test it later. So if you do this, you can bring all the copies. This is Python. So you have to choose Python. Okay. This is one that you can write to get all the items from bring all the items from a table. Okay. A table in the DynamoDB table. Something that you can do. What you have to do is just change the name of the table here, right? And then just be in the table, right? And see here, you know, the keys, the elements, you have to see. Maybe you can play with that. That's not mandatory. It's just in case you want to do it, right? Now, what I want to do is, are you still with me?
Yes.
Okay, so what I want to do is come here and create a Lambda function, right? Real quick. Lambda function, and I can call it stop my EC2 instances function. Okay. So I'm going to use Python. Okay. I'm going to choose a basic role for now, right? And I'm going to create the Lambda function. As simple as that. So simple, right? So I created a function for me. As you can see here, this is the ARN of that function, the Amazon resource name. Okay. Permissions that I have right now, I have just to roll by action, just to roll here, right here. This role was created for me. Okay, that may not be enough. Okay, I'm going to create the function now. So I'm going to delete this guy. Right. I don't need that. So I'm gonna just import Boto 3. Okay, that's the SDKs for Python. Okay, so now I'm going to declare a variable. I'm gonna call it region, and then I'm gonna put US East 1. Okay. That's the region. Now the instances, I want to just put this here. because I don't know yet what I'm going to stop, right? Now, I want to bring the instances here. So I'm going to say Bodo 3, that client. And then I'm going to say, I want EC2. And then the region name, the region name is going to be region. Okay. So I'm assigning this region here, right, to the variable region name. Okay. And then I'm telling that the resource that I want is EC2 instances, right? Now I'm going to create the function, the handler. It's called the handler. Def, this is for Python, okay? Def lambda handler, right? And then I'm going to say event context. You don't have to understand this fully, right? And then I'm going to say EC2 stop instances. Remember the command in the CLI? Same thing. Okay. So I can say instance IDs equals instances, right? That's the variable here that I have here. Okay. So whatever number, whatever ID I put here is going to be assigned to this guy. And then Python or Lambda is going to know what instances are referred to stop it. Okay. So now I'm going to print instances have successfully been stopped. Okay. Right. They are, and then I can say plus str instances. So what it does is that, I mean, this is a little complicated for you guys, but you need to understand that what I'm saying is instances have been successfully being stopped. They are, and then the instances is these instances here. Okay, so we're printing these instances. Now I need to go to my EC2 instances console and there grab the IDs of the instances that I want to stop. Okay, so I have this one here first. Okay, so I can put it here. In the lambda function, where's the lambda function? Okay, I can put it here, right? And then I can put another one here. The second one. Okay. Okay, so we have two instances here that we want to stop. All right. They're going to be stored here, right? And then we're going to say this, stop them, right? Now let's test this lambda function. Let's see if it works. So you can save it and then test it. Let's see. Let's go here, my event, and let's see if it works. Okay, test. You know, we have a problem here. Remember what I told you about the role? Okay, the role is a basic role. I cannot do this operation. So I have to edit the role. I have to come here and here, go to IAM. And IAM, this is the role that I have, but it doesn't have, if I take a look at the policy, okay, there's nothing here that allows anything with EC2. Okay, there's no permissions here for EC2 instances, right? Nothing here says EC2. I have to add a policy. Okay, so I can attach a policy and I can say EC2, right? And I can come here, EC2 full access. You see here, EC2 full access. So I can attach the policy, right? And then attach the policy here. Now My Lambda function has complete control on EC2, action EC2, I can do anything, okay? And this policy will be applied immediately. So I can come here and test my function again, and it works now. You see? It says EC2 have been successfully, and they are these two. Now, if I come to my EC2 instance console and I do this, look at this, stopping. You see? So far, we did it manually, right? We tested it, right? We want to automate this. What service do you think that I can use to automate this, to schedule this? What do you think? What services do you think? Let me see the answers here. No, not autoscaling. The answer is CloudWatch. Okay, CloudWatch is the answer. CloudWatch is the service that will help me automate this thing here. Okay, so my instances are back and running. Okay, now I'm gonna go to CloudWatch. Okay. So in CloudWatch, I'm going to create an event. Okay, I'm gonna create a rule. So in the rule, I'm gonna look for the service. I'm gonna schedule it. Okay, I'm gonna schedule it. So fixed rate, no. What I want to do this is a cron expression. Cron expression. If I go to cron expressions, in AWS. So we can have these patterns here that we can use, right? So let me bring this here and I will minimize it here. And then I'm gonna bring, let me see, where's CloudWatch here? So I'm gonna have this to the left. One moment. To the left. And this to the right. All right, good. So, so we have this here. Minutes can go from 0 to 59, okay? And then you can use wildcards. The star means that it's every single minute, okay? Whenever you see a star, that means every single minute, every single day, every single hour, every single year, whatever. So we want, and something that we have to understand is that this is in UTC. I think it's UTC time. UTC, let me check when I do it. So the first one is the minutes, right? So let's say that we want to stop the instances. What time is it? It's 4:08, right? How long will this take us? Probably, sorry, 5 minutes probably. So I'm gonna say at 4:15, right? So I'm gonna put here 15, right? That's gonna be the minute 15, minute 15. Hour from 0 to 23. Now, this is gonna be in military time. So 4 is gonna be 16, right? So that's gonna be 16, right? The day of the month is gonna be, what day the month is today? Today is the 15, right? 15. The month is gonna be month 5. That's May, right? If I put a start right here, it's gonna be all the time, right? Now, month, day. So I can say from Monday to Friday. Okay. And the year, I'm gonna say every year. Okay. So here I have a cron expression that is telling me every day from Monday to Friday at 4:15 in May, just stop the instances every year. But we're gonna have a problem here because this is in what time it's I think is, let me see, I think it's UTC. So I'm gonna choose a lambda. The target is a lambda function. That is the one that's gonna be triggered by this rule. Okay, so I'm gonna choose stop my lambda functions. Okay, so let me see something here. This is in UTC. UTC. Okay, so what time is right now UTC? Let me take here one moment. Okay, UTC right now. UTC time. So it's 11 p.m. It's 8:11 p.m. So we have to put A. Okay, and 8 is 20, right? 8 is 20. Right? Are you understanding, guys? There's 4 hours ahead of us, UTC. So we have to put 20. Okay, for that to happen at 4:15 our time. Okay, so then I'm gonna give it a name. Stop EC2 instances. Okay, rule. And then we're gonna create a rule. All right, that's an invalid name. Okay, and then we create a rule. All right, let me go back. Let me say day of the week. Today is the 5th day of the week. Okay. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. I think that's okay. Okay. Let me do it. What time is it now? 13. I think they put it here. 18. Let me see now. Oh, not valid. Parameter schedule expression is not valid. Okay, let me see. What is this? 15. Okay. Hours. Day of the month. Okay, every day of the month. Say here. Month. Let's say every month. Okay. And let's say here every day. Okay. Let's see what happens now. Okay, still having an error. I don't know why. Let me see. CloudWatch events from down there. Okay. Kind of expressions. Okay. So give me an examples here. Let's say 0, 10. Oh, day of the week. Okay. Okay. Let me see. 2018. That will be 4:18. What time is it right now? I think we still have time. It's gonna be GMT. 4:18 GMT right now. GMT time to see if we are correct. It's 8:14. We're perfect. Okay. And now I think that we're done here. So it's going to happen every day of the week, every month, every year at 4:18 Eastern Standard Time. So now we configure this, and then boom, done. Now, right now is 4:15, so we should wait 3 minutes for the instances to stop. Okay, and then I can have another rule for the instance to start tomorrow at 8 a.m. or from Monday to Friday at 8 a.m. So this way, I am automating my architecture using CloudWatch. I think that's pretty useful when it comes to, just being relieved of many, headaches that, doing things manually bring about. All right. So right now is EC2 instances. Right here we have 2. Okay, that will be stopped at 4:18. Okay, we just need to wait. It's 4:16 now. In the meantime, guys, do you want to add something? You want to add something? Is there something you want to add? The guys that are still with me? No?
No, I'm fine.
We're just waiting, right?
Yeah, wanted to see.
You want to see magic.
All right, so we still have 1 more minute, I guess. Whenever you want the time to pass by fast, you still have to wait. Okay. So do you have any special plans for the weekend?
Study.
That's the triad.
Yeah, I have to catch up with all your videos and everything one by one.
Okay, Amado, bye. Have a great weekend. You can watch the video later.
Bye, guys.
It's just 1 more minute and that's it.
Yeah, I'm looking.
Yeah.
Have a nice weekend. Bye.
Bye.
Bug match.
There you go. You see?
Awesome.
You see the magic?
Yeah.
So
Super magic.
you can schedule that every day. Okay.
Right.
By just changing the rule. That's it.
Yeah.
Okay. So you can automate your infrastructure like that. All right.
Right.
Guys, I hope you enjoy this and more to come on Monday.
All righty.
Okay.
Thank you very much.
Thank you. Thank you very
Okay,
much.
bye. Take
Sure.
care.